Hello, Math 130 students. We will continue lecture on page 24, section 1.6, which is talking about the absolute value equations. So an equation in the form absolute value of x is equal to a is called an absolute value equation. So what does this really mean? So whenever we have absolute value, you can think about it as, hey, we are on the number line. And one number that's really important is 0, right? And then we have our other numbers like 1, 2, 3. And you keep counting and you eventually get to positive infinity. And you also have -1, -2. And that keeps going off until you go off to negative infinity. So the absolute value, what this is telling you, is the distance from 0. Okay. So on the number line, you want to think about the distance from 0. So if I have the absolute value is equal to 6, that means, well, I went 6 in the positive direction, and I got to the number 6. And I also went 6 to the left, and I got to -6 here as well. So then my answer is a +6 and a -6. Okay? All right. So solving absolute value equations of this form. Well, we know that whenever the absolute value is isolated and it's equal to some number, whatever that number is, so let's just call that your unknown number. Who knows what that is? But whatever it is, it's going to split up to the positive and negative of that value. For example, if we have that w, the absolute value of w is equal to 5, then the values of w is going to equal to 5 and -5. Remember, if you were on the number line, and if you went over +5 and -5 from 0 on the number line, well then you went over 5 spaces and you got to 5. And you went over 5 spaces and you got to -5. Okay? Now, if we are going to say that if we are on the number line, we're at 0, and we have our positive infinity and negative infinity. Well, if you are telling me that the distance from 0 is negative, well, that's like me saying, yeah, I commute to work and I drive -3 miles, right? Well, that doesn't make sense. So what you say is no solution. Like, no, that's not possible. Distance can never be negative. So it can never, ever, ever be negative, right? Just like measurement can never be negative. If measurement, distance, or even time cannot negative, then something is weird. Like, go back, check your solution, what's happening, like, did you go back to the future? I mean, I don't know, but it just didn't work out. So let's look at the examples below. So for number 1, I have the absolute value and it's isolated. So we are saying that the distance from 0 is equal to 8. Well, if you go 8 in the negative direction, you get -8. And 8 towards the positive direction, you arrive at +8 on the number line. So my answer is going to be -8 and +8. For number 2, the absolute value is not isolated. What's messing it up is that +7. So I am going to subtract it first. So that the absolute value of w is equal to a +3. So then w is equal to your +3 and your -3. And for number 3, you're saying that the distance from 0 is equal to a -1. Distance can never be negative. So we are going to say no solution. And you don't have to write all of that, what I just did. I'm just trying to really show that you're going to have no solution whenever that value is going to be negative and the absolute value is isolated. Okay? All right, so now let's go ahead and solve for these absolute values. And we are going to follow these 4 steps to make sure that we can arrive to some solution if possible. So step number 1, it says isolate the absolute value. Well, I can tell you for this first example, the absolute value is already isolated. So that checks off our first one. Now for number 2, it says if the absolute value, so let's see the value of 9, okay, if 9 is less than 0, then there's no solution. This is saying, hey, if 9 is negative, there's no solution. But here, 9 is positive. So I'm going to skip number 2. We only worry about that if it was going to be a negative value. So step number 3 says, hey, rewrite the absolute value in 2 different equations, a positive and a negative. So now what it's asking me to do is to split this. So I'm going to have 2 different parts. So for my part A, I'm going to have that 4x plus 1 is equal to, and here it says for the positive, so positive 9. For part B, it says, hey, you're going to rewrite this thing in the middle, that 4x plus 1 gets written on both sides, so that's the same. But now, since you already wrote the positive, write the negative. So it's going to be a negative 9, okay? So that 9 is what got split up into a positive and negative. Now I solve each part individually. So now let's say to solve for part A, I will subtract 1 from both sides. Now to get that 4x is equal to 8. Now I would have to divide by 4 on both sides. So if I divide by 4 on both sides, then x is equal to 2. So I have my first answer. Now for the part B, I would subtract 1 from both sides. And notice how my value is going to be different. Now I'm going to have that 4x is equal to a negative 10. Now I would divide by 4 on both sides, so that x is equal to a negative 10 fourths. And I can reduce the fraction. I can divide both numbers by 2, or I can use my calculator to give me a negative 5/2. So now I have my 2 different answers for number 1. Now for number 2, remember I'm following these steps, okay? Oh, so I'm not done, right? So I did 1, 2 didn't apply. I just rewrote 3. The last step that I almost forgot was check the answer in the original absolute value equation. So, okay, this is where I'm going to bring up my calculator. So I want to make sure that if I plug in a positive 2 into this, it's going to equal to a 9. So if you have this calculator, and remember you can download this for free right now, I would go to Math. I would go over to ABS, which is my absolute value. Now I would plug in that 4. And now this is the value that I'm plugging in for x. Let's say 2. And I'm also going to have my plus 1. And once I press enter, it should equal to positive 9. If it does not equal to positive 9, then something went wrong. So let's try it. It's a positive 9. Perfect. So I know that I checked off positive 2, and it works out. Now let's try that next value, which is that negative 5/2. So I would go to my math. Now go to my absolute value, which is my abs. Now I'm going to write my fraction. You can write it as just, well, it says 4 times your fraction, so 4. You can put parentheses, and you can put in a negative 5 divided by 2. You can just enter the fraction that way, and then just remember to close your parentheses, and you have a plus 1. And so when I press enter, it should equal to positive 9. Perfect, it does. So now you've checked the answer in the absolute value. So now we've checked it. So now we've completed parts 1, 2, 3, and 4. Sometimes when you plug in those values into your original equation, it doesn't work out. So therefore you have to cancel it out and say not a possible solution. So let's go ahead and try part 2 now. Okay, we're going to do the exact same process for example number 2. So for this one, remember the first step, isolate the absolute value. Well, this absolute value is not isolated. Okay. And the reason why is because you have that plus 3. So you want to isolate the absolute value by subtracting that minus 3 to both sides. Otherwise, you can't even begin, right? That's your step number 1. So now I have my 3z plus 10 is equal to negative 3 plus 1 is a negative 2. So, okay, check mark. I have isolated the absolute value. I've done that, okay? Now step number 2. If a, which is our negative 2 value, if negative 2 is less than 0, then there is no solution. Well, let's think about it. Is negative 2 less than 0? On the number line, do I have sorry, I was trying to write my negative infinity too fast. Do I have negative 2 that's less than 0? Well, yeah, that's true. So what you're going to say for your answer is no solution. And the reason you say no solution is because distance can't be negative. So whenever you have the absolute value equals to a negative number, you cancel it. Okay, so that was awesome. We only had to do 2 steps to figure that answer out. So let's go ahead and apply the same principles for the remainders. So here, to isolate it, I am going to add 10 to both sides. So now I'm going to have 3, and this is times 2d minus 9. And since I added 10 to both sides, that's a 13. So you might be wondering, wait, how do you know that's times? Because here it tells you that this is multiplication. And from here, you cannot distribute that 3. The absolute value is not parentheses. Absolute values does not equal the same thing as parentheses. So that means you cannot distribute. That is not a good idea to distribute at all. So what you're going to have to do is you're going to have to, since it's multiplication, the opposite multiplication is divide. You're going to have to divide by 3. So now you'd have the absolute value of 2d minus 9 is equal to 13 divided by 3. Okay? So then from here, now that the absolute value is isolated, now you can split it up into its parts. So part A, you would have the 2, the absolute value is now when you can drop it, 2d minus 9 is equal to the positive of that value. And the positive value is 13 over 3. Part B of this equation is rewriting the equation as 2d minus 9. And now remember, this is where you split it into the negative of whatever that number is. So now, just using your calculator, I'm going to add 9 to both sides. So that 2d is equal to, now my calculator, 13 divided by 3. And then close the parentheses, and then you're going to add 9, gives you 40 divided by 3. So then from here, I'm going to divide by 2, which is the same as multiplying by 1/2. Oops, I'm running out of room here. So I can say that d is equal to, well, if I have 40 divided by 3 times a negative 1/2, you would get a negative 60. So for that answer, you'll have a negative 60. Now for part B, I have 2d minus 9 is equal to negative 13 over 3. So I'm going to add 9 to both sides. So that 2d is equal to, and again, I'm going to use my calculator, negative 13 divided by 3, and I'm going to add 9, and I'm going to get the fraction of 14/3. So I can divide by 2 or multiply by a 1/2. Both is fine. So that d is equal to now is going to be a positive 60. And you know, I just realized that I made a mistake, and that's okay. Sometimes mistakes happen. So I'm going to go back here and I'm going to say I did a typo. So I did a typo here and I did a typo here. But see how when I show all of my work, I'm able to see exactly where my typo went. So because I went too fast and furious with my fractions, I should have, that multiplication kind of messed me up. So I kind of thought of it as multiplication, but I turned it into something that looks like a subtraction sign. So really I did that incorrectly. So then that answer is going to be wrong. So let's bring that up on the calculator, okay? Just to make sure you know what I'm talking about. So I went too fast. So if I have my fraction of 40 divided by 3, and I'm going to, let's say, multiply by a 1/2, then my answer is going to be this. It's a decimal. I don't want a decimal, so I'm going to turn it into a fraction. So I'm going to go to math. Now it says number 1 fraction, so press enter again, and I get a 20 over 3. That should be the correct answer, 20 divided by 3. So there it is. So d is equal to 20 divided by 3. Now for my next one, same thing. I'm going to have my calculator. Now I'm going to do the fraction, which is 14 divided by 3, and it's going to be times a 1/2 fraction. And to turn it into a fraction, I go to math, and I press enter twice, and I get 7/3. So I'm going to get my answer as a 7/3. So the very last thing I want to do is check these answers in my original equation, okay? So I'm going to go ahead and bring up my calculator just to make sure we know how to do this. So this is 3 times the absolute value. So I'm going to go to my abs, and I'm going to have my 2, and now for the first one, it's going to be my 20 divided by 3. Close your parentheses, minus 9. Go outside the absolute value and press minus 10. When you press enter, it should equal to 3. If it does not equal to 3, then it means that that solution did not work. It's equal to 3. Perfect, that's exactly what I wanted. So I definitely know that this answer works out. So now let's try it with 7/3. So what I can do is I'm going to rewrite this. So I have my 3 and then my absolute value of 2 parentheses, and now that fraction is going to be 7/3. And I close that fraction, minus 9, and outside of the absolute value is minus 10. This should also equal to positive 3. It does. Perfect. So now I know that both the answers that I just got work out. So I did all of my steps. Now going with number 4, well, I have this absolute value of 7y is equal to 0. Well, if I were to split it, remember, can I have a positive 0 or a negative 0? Is that even possible to think about? Well, remember, on the number line, if I have 0, we have positive 1, positive 2, positive 3. And over on the negative side, we have negative 1, negative 2, negative 3. So is 0 positive or is it negative? Well, 0 is neutral. It is not negative, not positive. So when I have a problem like number 4, what I'm going to do is just drop the absolute value sign. So I'm going to have 7y is equal to 0. Well, to get the y by itself, divide by 7, divide by 7. So that y is equal to 0. 0 divided by anything is equal to 0. And let's see, does that work out? If I plug into my calculator the absolute value of 7 times 0, and remember 7 times 0 is 0, so the absolute value of 0 is 0, then you know you've checked your answer. Okay, so now for number 5, this one's slightly different. This one's going to be slightly different because you have an absolute value is equal to an absolute value. So I'm going to rewrite it just because it's kind of messy from above. So I have this negative 7d minus 8 is equal to the absolute value of 9d plus 3. So from here, these are both absolute values. So if these are both absolute values, then what you're going to do is you're going to split them up to the positive and the negative of it. It doesn't matter which is which. I don't care if you do the left-hand side as positive, negative, or the right-hand side as positive or negative. But one of them has to stay exactly the same, and the other one is going to turn into the positive and negative. So let's say we're going to choose this side to be split into the positive and negative new equations. So now in reality, this is going to change. So for part A, I'm going to have negative 7d minus 8 is equal to, and this is going to be the positive of 9d plus 3. Okay, so I've just split it into the positive value of it. Now for part B, I'm going to have the exact same value, negative 7d minus 8 is equal to, and remember now I'm going to split it to the negative of 9d plus 3. And notice how it's really important for me to put it inside parentheses because it's more than one value. So whatever is in front of it, whether it's a positive one or a negative one, it gets distributed on the inside. So here I'm going to have a negative 7d minus 8 is equal to now, and this is a positive, 9d plus 3. So now to get the d isolated, I'm going to add 7d to both sides. So it cancels over here. And I have negative 8 is equal to, and 9 plus 7 is going to give you a 16d plus 3. So I can subtract 3 from both sides. So negative 8 minus 3 gives you a negative 11. It's equal to 16d. So then from here, I am going to divide. So divide by 16, divide by 16. So that a negative 11, 16 is equal to d. Now I'm going to do part B. So for part B, remember I had to turn it into the negative value as well. So you can think of this as a negative 1 that gets distributed inside the parentheses. So now I have a negative 7d minus 8 is equal to a negative 9d minus 3. So I am going to add 9d to both sides. If I have negative 7 plus 9, then I'm going to have a positive 2d minus 8 is equal to a negative 3. So now I'm going to add 8 to both sides. So that 2d is equal to, and a negative 3 plus 8 is equal to a positive 5. So if I divide by 2, I end up getting that d is equal to a 5/2. So this is where I'm going to grab my calculator and go ahead and try these values. And just know that I did, and both of these work out. I just don't want to make this video too long. And now for number 6, again, I want to isolate the absolute value, so I'm going to subtract 3 from both sides. So that 5u over 4 minus 7 is equal to an 8 minus 3 is going to equal to a positive 5. So when I split this into the positive and negative values, part A, I have 5u over 4 minus 7 is equal to that positive 5 value. And part B, we have the same thing, 5u over 4 minus 7, and now we're going to have that negative value, so that negative value is a negative 5. So the first thing I'm going to do is add 7 to both sides. So that 5 over 4u is equal to, and if I have 5 plus 7, that's going to give me 12. Now I can multiply by the reciprocal. So I have 12 times my fraction of 4/5 and get a 48 over 5. And for part B, I will add 7 to both sides. So that 5u over 4 is equal to negative 5 plus 7, which is 2. And I can multiply now by 4/5 on both sides. So that 2 times my 4/5 is equal to an 8/5. And just know that I did plug in both of these, and these both work out. So I did check them. I don't want to make this video too long. Okay, now this is where the fun really begins. So now we go from just equations. So this was in the last section, so last page. Okay, so this is, hey, remember what I said like 10 seconds ago? So that was with the equal sign. So that's a huge difference here. That's because it had the equal sign. Okay. Then we knew it was going to equal to the positive or the negative of that value. So I said, you know, for example, if x, absolute value of x is equal to 5, then we'd have 5 is equal to a positive 5. And I also said that x was equal to a negative 5, right? That's how I split it up. That's what I just talked about. Now we're going to throw some more information at you. Now we're going to deal with inequalities. So if it's greater than or the option of greater than or equal to, then what that means is that you're going to split it up, and this is going to be kind of like your formula that you plug it into, right? Your format. Now if you have the absolute value of x is less than, or the alternative is less than or equal to a certain value, then you're going to change it into a compound inequality, right? That's where it's being squeezed in between both the values. And of course, your kind of weird exceptions, if you have the absolute value is greater than a negative number, remember distance can't be negative. Well, if it's greater than, you're going to say all real numbers. But for that last one, if the absolute value of x is less than a negative value, then we are going to say that it's no solution, because distance can't be negative. Okay, so let's go ahead and try this out. So the first things first is we need to isolate the absolute value. So I'm going to subtract 1 for both sides. So now I have the absolute value of 3x minus 2 is less than or equal to 4. So now that I'm here, I'm thinking, okay, well, which rule am I going to use? Well, it's not an equal sign, so I can't use that one, so that one's gone. So which way is this one facing? So if I'm thinking about it, I have this as less than or equal to. Oh, this one is less than or equal to. So I'm going to be using this format. So remember, my a value here is really that 4. and that x is everything inside the absolute value. That's everything that's unknown. So if that's the case, well, I know that the negative of that value is a -4. And I have less than or equal to. Everything that's still in the absolute value gets written down. And then I have my +4. So because of the way the inequality is facing, that determines how I'm going to be writing this, okay? And so it's going to depend on what your original equation that you got. So now that this is what I have, well, to get the x by itself, I'm going to add 2 to both sides. So I can have -4 plus 2, which is a -2. And 4 plus 2 is 6. So now I can divide by 3, so that -2/3 is less than or equal to x, which is less than or equal to a +2. It says solve and write the solution in interval notation. So for this interval notation, remember that's the thing that either has the parentheses, the brackets, the parentheses and brackets, or the brackets and the parentheses when it goes from your minimum value to your maximum value. So you're just like, oh yeah, that thing, I remember that. Well, okay, it looks like the smallest number is going to be a -2/3. And I have an inequality that says less than or equal to, so I'm going to have a bracket. And so that is my smallest or my minimum value. So my biggest or my maximum value, it looks like it's at 2. It's x is less than or equal to 2, so that's going to give me a bracket. So that is going to be my answer for number 1. Now, looking at number 2, well, now I'm going to be looking at which way the inequality is facing. So here, the absolute value is already isolated. Perfect. But now I have this greater than. So this greater one is here. So this is going to be the formula that I follow. So I'm like, okay, well, if that's the case, then it says I'm going to write everything inside the absolute value as a 3x minus 2. And it says it's going to be greater than that value of 4. And then it says or. So I'm going to go ahead and write the word or. And then it says that stuff inside the absolute value, so that 3x minus a 2 is less than. And now it has a negative value, right? So now it's going to be a -4. And I guess if you're trying to color code this, this would be your +4. That would be your -4. I know a lot of you guys try to use the same colors as I do, so if you're trying to keep the same rhythm, it's a blue 4 and green 4 for your positive and negative. Okay, so now that this is the case, I wrote it down because that's an inequality that I have, and now I have to solve for x in both equations. So I'm going to add 2 to both sides, so that 3x is greater than 6. Now I'm going to divide by 3 on both sides, so that x is greater than 2. And don't forget, I still have the word or, and I'm going to have to add 2 for my part B equation, so that 3x is less than -2. Divide by 3, divide by 3. I'm going to have x is less than a -2/3. So if you want to visually, if you're a visual person, that's okay, so am I. So if I'm thinking about this, well, I have a +2 and I have a -2/3, right? It's negative, so I know it's on the left-hand side of 0. So for the very first one, it tells me that x is greater than 2. So x is greater than 2 looks like this. For the second one, it's saying that x is less than -2/3. So that one looks like this. And I have the word or. So hopefully you remember from a few sections ago that if I were to say or, then it would mean the union. If I have the union, that really means everything. So that or tells me I'm going to write the union. So let's start with the piece on the left. The smallest value here it goes to would be to negative infinity. And the maximum or the biggest value is a negative 2/3. And since I have the word or, this is union. And on the right hand side, I'm going to have that x is greater than 2. Oops, I'm writing in interval notation. Lost my place there. So I know this is going to be the smallest value at 2 and the maximum value at positive infinity. Okay, I hope that helps. Well, now let's look at number 3. For number 3, it says 4x minus 3 is less than 1. So which formula does this one follow? Well, the formula, and you can have, your flashcards, but since I have the absolute value of x is less than a, that's the formula that I'm using, then I'm going to say it's going to be negative 1 less than the stuff inside the absolute value. So maybe I'll just write the inside stuff. Right? And it's going to have my positive 1. So now I know that this is going to be my negative 1. Now the inside stuff, that's that 4x minus 3. And I have my positive 1. So now I'm going to add 3 to all 3 sides to cancel it out. So I have a positive 2 less than 4x less than a positive 4. So now I divide everything by 4. So that I have 1/2 is less than x less than 1. So now I know that my minimum value is a 1/2 and my maximum value is a 1. So that goes from my minimum to my maximum. Now for number 4, I can't apply the rule yet or the formula because I have not isolated the absolute value yet. So here to isolate it, I'm going to divide both sides by 5. So now I have x plus 3 is greater than or equal to a positive 2. Okay. So now for this one, I'm going to have to look at its own formula. Right? So the formula is going to represent the absolute value of x greater than or equal to some value a, right? Where this value is going to be a positive 2. I just want to keep my notes consistent. So because I have this, then I'm going to rewrite my formula here. So I just wrote it out. I paused it because I need to go up and scroll up and look at my stuff. So remember, the absolute value is greater than or equal to a value, then you see the inside stuff is greater than or equal to 2, or the inside stuff is less than or equal to negative 2. So I'm going to go ahead and split this into my 2 equations. So for my first equation, I'm going to have the inside stuff, so that's the x plus 3, greater than or equal to a positive 2. Now for my part B, I'm going to have the inside stuff, so that's going to be my x plus 3. Now I'm going to say less than or equal to, and now I'm going to have my negative 2. So I'm going to subtract 3 from both sides, so the x is greater than or equal to a negative 1. And over on this side, I will subtract 3 from both sides, so the x is less than or equal to a negative 5. And remember that this has an or. So the or represents union, which represents everything. So if you are drawing it, I think sometimes just drawing helps, especially if you are a visual person. Remember that 0 is right smack in the middle. So if I were to have my negative 1, and have my negative 5, So at -1, it's greater than or equal. Oops, I color coded that wrong. There we go. And then at negative, and that was supposed to be a -5, yeah. So at -5, it's going to be less than or equal to. So I would rewrite this for interval notation. Your smallest value is -infinity to a -5, and that is a bracket union, and that blue inequality is a -1 bracket union to a positive infinity parentheses. And remember, I'm going from my minimum to my maximum and my minimum to my maximum. Okay, so we have 2 last examples to go, and let's see what happens here. Well, for number 5, I would subtract 7 from both sides so that the absolute value -6 is greater than or equal to a -8. You might want to stop. This is absolute value, which is distance, and you're saying that it's negative, you should pause. Distance can never be negative. So what special property is this? So if I have this as greater than or equal to a negative number, I just don't want to confuse you by having more writing, and it was greater than or equal to a negative number, then I'm looking at here. If x is greater than or equal to a negative number, then I'm going to have my interval notation from -infinity to infinity, and I'm going to say all real numbers. So all real numbers. And it goes from -infinity to positive infinity for your minimum and maximum value for your interval notation. Okay, well, let's see what happens with number 6. With number 6, I'm going to subtract 8 from both sides. So that 4 minus 2x is going to be less than, and here I have 8 minus 8, which is going to be 0. So if we have this less than 0, then we can just drop the absolute value because 0 doesn't get split up into the positive or negative values, right? 0 is the only number that can't be categorized as negative or positive. So since that's the case, we can just think about this as 4 minus 2x less than 0. Solve for x. So to get rid of the that positive 4, I would subtract 4 to both sides. So I have a negative 2x is less than a negative 4. Divide by negative 2 on both sides. So that x, and remember, whenever you multiply or divide by a negative value, you're going to switch the direction of the inequality. So now, negative 4 divided by negative 2 is going to be a positive 2. So on my number line, if I'm looking at positive 2, it looks that way. So I go parentheses 2 all the way out to a positive infinity. All right, if you guys have any questions about this section, please feel free to email me or contact the tutor or go to the Math Success Center or practice on your homework. All right, thank you.